All right, everyone. Thanks for coming. Welcome to all you online viewers. Hope that we see you back in person next year. ClueCon's been around since 2005, and this would be the most hybrid we've ever gotten. You know, we've been working on video technology for years, just even before SignalWire, in the FreeSWITCH project. So we've used this conference as a test bed for many of our early developments in video. And, you know, it was a good thing we were working on that because we really needed it this year, right? We have trying to get ourselves out of this pandemic situation, which makes it a lot harder to communicate, but it also inspires us to create cool technology. So welcome to you guys online. You're all on the stage so everybody can see you. So feel free to unmute. If not, you got your cute little characters. So yeah, we're gonna just talk a little bit about where we came from and what it means, what a developer actually is. So shortly after the first ClueCon, the inspiration came from that conference to create FreeSWITCH for the first time. Many of the early attendees are now, you know, longtime members of the project. We had the conference, you know, to try and figure out how to do a new chapter and what he had already done so far in voice over IP. So, you know, we have, I don't know, this is the 17th ClueCon. So after that many years, we're continuing to try and figure out what else we can do. And one of those things in the last 3 years was to start a company called SignalWire. We originally, as an open source project, we're all volunteers. And then when we wanted to do more than what we could do in our spare time, we started getting employed by people who would sponsor our project, and we made things with it. And one day we decided, you know, instead of looking around at who's going to sponsor us for the next year, like, let's start our own company and be our own sponsors, which was a lot of independence for us. One of the main reasons that we did that, because the problem got much bigger than the spare time of a few engineers. So at SignalWire, we have products, and those products are centered around a few categories. And one of them is FreeSWITCH Enterprise, which is some really large organizations have built stuff out of FreeSWITCH. It goes into the massive scale where they have lots of particular problems that have to do with enterprise customers. So we have that. And then we have SignalWire Cloud, and that gives us the ability to put some of the complexity of voice over IP into a hosted cloud platform so we can do things without manually installing them all over the place. So we have our own kind of branded, clustered ability to send messages and receive calls and do interesting behaviors on them and try and distill it down so developers have something to work with. And the last project that we're currently, say, in the midst of mid-development is SignalWire Call Fabric, which really brings everything home that we've been doing over the many, many years to allow you to build and host your own infrastructure in the cloud that is complemented by the last mile being your own setup or whatever makes your stuff interesting. So hosting and controlling users for you, and think of it like a program X, if that's the way you want to look at it. Think about it as a system that's always there for you, that is extensible, like, into your own equipment, into your own business logic. We're trying to separate those things out. And that's what we've been sort of working on since we started the company, but it doesn't just happen. We've been working on it for years and starting to culminate. This is probably the first time I'm actually talking about that to anyone. So keep your eye out for that. So the mission at SignalWire is we want to change how people communicate and work and collaborate. And work is interesting right now. I'm a remote work person since I was about 24, back in the Stone Ages, and I've always worked remote. As soon as I realized it was possible, I worked remote. That used to mean finding a place that had the internet, but at least wasn't an office. And then it got to be anywhere a little dongle will let me work from. But all the time we made FreeSWITCH. One of the reasons we made it is we were using the internet as the basis of communication, and we chased the internet here, FreeSWITCH and SignalWire, because the internet is kind of like this catalyst for everything. So we were working remote for, I think it was 13 or 14 years at the time SignalWire began. We founded SignalWire to be remote. Lately, everyone is working remote. They kind of have to, but this is kind of one of the places, this environment at ClueCon, that was really kind of the origin of some of the technical remote work, all the different conferences like this, because us engineers learn how to do this first, because we're the most, I always use the term lazy, but it's a different kind of lazy. It's the ADD kind of lazy, where you actually, you do a lot of work, but somehow you're still driven by doing less work. And they have those jokes about how we will spend an hour trying to make something that takes 5 minutes, takes 4 minutes. So that's what we're like. We like to work remote. We like to bring everything on our backs, be able to set up laptops and do 10 things at once. We're still working on trying to get the rest of us, other jobs besides engineers are now getting to learn this kind of cool ability to kind of bring their life with them. And the faster the internet gets, the sooner that comes true. Now, one of the things that we really care about, especially throughout all these years, are developers. In the early days of FreeSWITCH, the entire group was developers, right? All the users of FreeSWITCH are developers, the core developers of FreeSWITCH. Our company used to only have developers in it when we first started it, our earliest company around FreeSWITCH. So, we had a lot of growing up to do when we started bringing in roles that were outside of the realm of just developer. But because of that, it's kind of ingrained in our mindset, like developers are who we care about. So one of the experiments I did when I was preparing for this was, like, what exactly is a developer? I've wondered about this, like what the world thinks of it, trying to make sure I am communicating what I think a developer is. I know what it means. Everyone that comes to ClueCon tends to contain a lot of developers. What does that mean in the wild? What does it mean when you're trying to message that out to the world? I looked it up in the dictionary to see what it meant, and all they said was someone who develops something. So that gave me a lot of leeway. But I was like, I really want to think about what I would call it with my own invention of a definition. So I said, someone who narrows the vast scope of possibilities offered by computers and the internet into something with specific purpose, usually enrich the life of other consumers. Now, to me, this includes the product managers, people that are thinking about how a product should work, but also the designers who make the interface to the people trying to convey the stuff. So like working on a product is developing, right? In general, it's like you're taking an insane amount of random possibilities and narrowing it down into something that actually communicates and serves a purpose for somebody. So that's what we think of developers here. So another thing we talk about a lot, I have this sort of ongoing blog series about take buzzwords. Like when it sucks when you go to use a word and it's a buzzword. And then you end up with, sounding like a hipster because I already used APIs before everybody else, but, we use APIs as a term here because we've always been. And we've been using APIs ever since. We wrote code in C and FreeSWITCH, and an API back then just means like header files and library and like a part of the software that you're loading into other software and stuff like that. And this Webster dictionary kind of is still talking about that. If somebody wants to bring me some water, that would be cool. Sorry about that. So an API in the modern era, besides just meaning something that wires software into another software, which we already know that means, I kind of come up with what I believe it means, a way to provide complex, powerful services to developers in an easy to consume interface. So even though the golden term of what an API is now evolved to mean these cloud and REST APIs. There's all different kinds. A lot of times when we're talking about that, like we have a sign here, video APIs. What does that mean? We're using the internet to try and deliver some of our stuff. So rather than just doing it through pure software connection, like loading libraries and stuff, we're sending in part of the stuff over the internet as well. Either remote controlling broadcasting equipment or live video and audio, or whether it's like data messaging, pipelining, trying to interface an event system. There's all different kinds of ways to do that. So that's what we mean about this. And then looking at how do we look at APIs. This is a term I use a lot, like comparing it to fractals, because APIs kind of go into when you look at an API inside of a program, it's almost like a little program inside the program, right? Every different function. If you zoom out, then your program does something interesting, but then your program also is part of another bigger system that's a collection of programs. So the more you kind of zoom out from it, you're still sort of seeing the same kind of stuff. So we make it, the farther away you get, say, from bare metal, meaning right on the computer, sometimes the easier it starts to look. But the usability and the interface and everything is still the same. And that's one of the ways we also scale to the rest of the world, is rather than the entire world only being able to deal in absolutes of small software, like right on a computer, they're talking to the entire internet and allowing all the scalability to happen for them in a lot of different ways. So if you start with an operating system, so you've got a computer, it has all kinds of fancy things it can do. And you need a way to communicate with it. So the operating system was a result of programmers being pretty tired of like rewriting they used to have like one software driving the computer, and then every time another one would come out, they'd have to write it all over again. So out of that, operating systems began to evolve because it was like something you could build that was like a familiar environment for a developer to communicate with the computer they're running on. So you start at that lowest level and you bring the hardware up to the operating system. And then using FreeSWITCH as an example, because something I know pretty well, I took the operating system in my vision and said, let's extend that up another layer to be specific. So I wanted it to be about telecom and communication. So that platform was built to take the operating system, zoom out one more level. It was a set of functions and features that you could integrate with that would allow you to do telephony. So you got a module for SIP, and you want to make some IVRs for Moshe. You can do all those different things. So now we got more specific, but it was still a lot of the same concepts. So we zoom out farther, and SignalWire is another example. I like to use ones that I know a lot about that I don't have to do as much research. So, SignalWire is a platform that runs in the cloud, which is another buzzword, right? It just means the internet. That's a place where it can take all that complexity from, say, an entire army of 1,000 free switches at once, all over the world, trying to normalize and stretch your business logic to where it needs to be on the planet without having to worry about it, but still then provides APIs, but you talk to most of them over the internet. So we have really cool new, say, RPC interface at SignalWire that I'm sure you guys will hear about from other speakers, but we allow you to connect to us and all of that craziness through an internet socket. So that's kind of the whole purpose of why we built that. And it again is sort of the same paradigm, but it's farther and farther away from that bare metal of one computer. So the important thing about that when you're doing stuff for developers, because that's really what it matters. The reason we do all these things is we want to make life easy for developers. That was one of the things I got caught up in my career. So I started out, driven by just a passion to make something I had a good idea about. But all the time, I'm imagining other people struggling and developing, and like I'm trying to make tools for them, right? So sometimes it's hard to imagine that when you're building like an interface for somebody else, but it's really important to think about it. So what you have to do is, while you're making it, as much as you can, work together with the group even, and get feedback from early adopters. How do you make this so it won't frustrate people, right? You want to make it so if you're trying to build a product out of these interfaces and you're like, there's some blocker I can't because you don't have this one function or whatever. So that's like some of the considerations you have to make when developing stuff. You know, when I first started making FreeSWITCH, we just made it. We had to change a bunch of different things. The way people used it was repeatedly opposite of what we thought, and we ended up, we'll just change it to go along with popular belief sometimes, because that's like important. You know, other times we would teach people new paradigms, so it always like, it's a thin line to walk, but you have to be careful to absorb as much feedback as possible and think about developers, because what we're trying to do is actually make their life easier. We're trying to make a bargain where if you use this to build your stuff, then you don't have to do something else that's actually horrible and boring and you don't want to do it, or it's expensive, or there's a reason we're trying to simplify your life where you're trading one complexity for a value. So APIs are actually products. It's easier to look at like a vacuum cleaner as a product because you can spill dirt on the floor and like show how cool it sucks up and everything. But APIs are like a lot harder. They're like, it's like abstract concept. Where you're just trying to convince people that like if you use these functions in your program and you're like, what's a function? And you know, it depends on who you're talking to and how do you anticipate what everybody wants. But it's important to know that it's really a different way of looking at it, but not that different. Like you still, if you made cereal and you let people test it and everyone hated it, you would make the cereal differently, you know. So same with APIs, you have people try them. You think really hard about how to organize them. Sometimes you miss the mark so bad you have to make another entire version number of the API and try again, or other times it's like one little thing's wrong, or maybe you just need to add something. So those are always going on. And the product development cycle on APIs is actually pretty intense in that way. So one of the ways that we deal with trying to solve this problem, we have areas of focus. The most obvious one is solving for pain, right? So like, that's the, you know, the cereal tastes bad, that sucks. But sometimes the pain might be what someone's already doing before they ever tried cereal for the first time in their lives. You know, like they didn't even know cereal existed. So you find that pain point. Don't you hate having to cook every time you're hungry? Well, introducing cereal, like you just eat it out of a box, you know? So there's always kinds of that thing that you look for. And I don't know, I'm just using me and my group around me as an example, but my team doesn't like pain. We all complain about it, like stuff, like especially developers. Like not only are you really good usually at making stuff, but you're good at troubleshooting. So then you feel like the world's tech support because you go to buy a candy bar and the vending machine doesn't work. And you're like, there's a bug in this machine every time I press that button, and you learn it all, but no one cares. And so, you know, these pain points come out a lot. And so finding those in developers, they'll be your best friend if you could solve for that, because we're all tortured by so many different things like that. And that's really kind of why you're bothering anyway. Like you're making software to simplify people's life. So now you have to just take it one step further and simplify the life of the person making the software, and they will simplify the life of their customers, which is again why it's similar to fractals. The other thing is to design for expansion. This is another tricky problem because you want to be fast at making more stuff. So when you're choosing paradigms and how to make your APIs available, you have to make it intuitive. Like down in the early days of FreeSWITCH, we built an entire separate sort of area of the code that we wanted outside influence from. You know, so we have the core of FreeSWITCH, which was guarded by a three-headed dog, and we didn't want you to even send us a patch about that part of the code. But then there's like the module area where everyone adds their own code. And then there we gave APIs out, and we took advice from the, you know, feedback there and made it so we would expand. So once you learned that the way we did things, we tried to keep the paradigm the same. So when we came out with more stuff, you would just say, oh, I already know how to do this somehow magically, because it's like the exact same paradigm as anything else that I've ever seen from this. So we work on that in all the things we do, because we want to be able to invent new verbs into our remote procedure calls or new features, and we want them to be immediately understandable rather than like designing it completely different every time and having some kind of giant book you have to read to learn it. The other thing is community. We learned this. We probably didn't know that when we started. We learned it because it was just second nature to us. We built a community that used to have like 10 people in it. And it grew to the whole planet one day before, well, we were too busy to notice. One day we just realized like just the way we were doing things was bringing in, we can pretend like we were planning it the whole way and sound cool, but really it was like we were just doing what we thought made sense for ourselves, and it picked up and the group kind of followed. And so some of these things are important that we learned through that, though, because, this goes back to like prehistoric days when people lived outside around campfires and went to sleep in caves, and like they didn't have internet or books even yet, so they would tell stories around the fire about different things to preserve the knowledge, and that works a lot with programmers. It's a lot easier to storytell your way through why you had a problem and banged your head against the wall. This goes back to solving for pain again, because we all feel bad about it. There are a few trolls on the internet that enjoy the pain and the schadenfreude of like the only one that they're watching someone struggle and they think it's funny, but that's only a few of them. Most of us are like, I want you to do something cool, so I'm going to get you out of this jam you're in. You're going to spend like a week trying to figure this out when you have a million other things to do. So we like to tell each other stories, learn from each other's mistakes. And the networking out of it, the first generation of people who came to this conference, many of them are exited in some company they ended up starting, or they became a prominent executive in a company somewhere and the top of their field in development. And that all comes out of hanging out in the community for years. So also we like open source a lot, as made probably obvious by our immense software project that has millions of lines of code in it, but we spent years writing that because it was, the best way to do it. There's like, we could have a whole talk just about that, like what does open source actually mean and that kind of thing. But like to summarize it on my one slide, it's something that we do because it makes all those things I said possible. It accelerates the development of the software. So it isn't about because it's free or any of this other kind of stuff. It's about doing it in the open causes it to accelerate faster. So we like to take the pieces of our work that are the most reusable and have that as open source, right? So we have the whole FreeSWITCH. We just came out with a shake and stir library last year. And then we have like a whole GitHub full like SignalWire tools. Like say you want to make like video tools that we sell, we're starting to make like UI elements that are all open source you can run on top of it. So you don't have to spend a lot of time reinventing the exact same UI for controlling video chat and that kind of stuff. You probably want to take the video chat and embed it in your site or do something more interesting with it. So we keep as much of that reusable stuff open source as we can, and we have been for a really long time. And also, so then I'll give a little example about, we say a lot about software-defined telecom, which is really simple. It just means get rid of all specific equipment and use everything as software so that all the virtual compute in the world can be leveraged to make the internet driving them. So the internet infrastructure is the only one that we should be paying attention to. We're trying to build telephony infrastructure, it will all rot away. So by making everything in software, we can keep up with the internet infrastructure, which is outpacing any other infrastructure. Like if you get Starlink, you have a satellite dish, it's delivering the internet to you at many megabits in and out. That makes more sense than having one for your TV and one for your internet and one for broadcast. And you can just have a really good one in internet infrastructure and it carries everything on it, and we're no exception with telecom. So in the old days, telecom looked something like this. You had wires in physical offices, and that worked really well. Like I thought that was cool when I was a kid. The fact this like strange device could just like type numbers and call somebody and that kind of thing. So 1970 through the last 10 years probably did pretty well. In the 80s or so, and then mobile came out, and we started like augmenting that a little bit. So it was that first time I'm at the beach, I'm in the woods, and I can still call you. You know, that we got over that right away. But at first it was insane, right? I'm driving in the car. So, you know, then we got spoiled by that because now everyone just kind of has a mobile phone. But then in the idea of software-defined telecom, we're just flipping the paradigm on the other side where the internet is the thing that's mobile. And because it is, we can put telecom inside of it. And that just keeps being more insane because it could be like, I'm on my refrigerator talking to you. It doesn't matter what the device is or where it is, as long as the internet reaches it, you can go on it and you can use it to communicate with people. And if you are a product developer who's trying to make something, you can host the complexity somewhere where you know what will be, and just worry about your product. Like, say your product is a segregated chat system where you want it to not be, you don't want WhatsApp, but you want your own WhatsApp only inside your one company, because you don't want to have like this random, the whole world joining it. You want to brand it your own way. You want to control what happens. You want to have some kind of product where on the website you can talk to salespeople right away. All these different things where the communication is one of the ingredients, but you don't want to build the infrastructure part of it. You want to build the app itself, sell it to people, get customers. So with this sort of model, you know, the internet does all the work that makes everything possible, and then everyone else just wanders around with cell phones in their hand talking to each other. And we want that. And we want to get telephony so that every cell phone in the world uses just the internet, right? Like the internet is why you have a phone in your hand. It's not a phone anymore. It's a handheld computer. And then we will insert telephony into it over that internet connection rather than have any, you know, there's a lot to go on this because we need the internet to be fast. And everywhere, but 5G is here finally. I think it'll still take a while to roll out to everywhere, but we're getting insane amounts of bandwidth now that that were not even possible before. You know, and every time that happens, something cool results from it, right? When we had the first cell phones that were smartphones, you know, where it started to let you do more than one thing, you could take a picture on it or whatever. You used to have to get a little SD card on it, and then you'd have to like plug it into your computer and back it up all the time because it was cool and it was mobile, but it's still like it needed this kind of tethering every once in a while to get it back to sane. Like even iPhones, you had to plug it into your iTunes and sync it. And, you know, because the internet got so fast in the meantime, now it all just happens, right? Like you buy the phone and it just, as soon as you type your name in, it becomes the same as the other phone you used to have because it knows everything you were doing. And everything you did gets saved to the internet because the internet's so fast that every time you take a picture that's a couple megabits, it can just, you know, average picture is like 8 megabytes. Just takes like 3 seconds to upload it. So couldn't do that before. You have to save it all on SD card. So same deal with all your communication stuff. Once you have hundreds of megabytes all the time, then you'll be able to just instantly do a lot of these things and not even think twice about it. So that's the anticipation that we're riding with that. And we're trying to allow developers to take this brand new thing and make stuff. But I also thought, since we're talking about developers, that I would explain the mentality of what we think about, because I think it's helpful to everyone. We're not the only company trying to make stuff for developers. And if anyone else is, you know, practice what I preach. I'm just trying to tell everyone about it because I don't want you to suffer. So that's pretty much it for the slides and me babbling. And if you guys want, I can chat if you got any questions or anything. Thanks.
All right. Thank you, Tony.
Yep.
So at this time, we'll be doing a Q&A session. We've got a few minutes. If anybody has they would like to ask, feel free to step up to one of the 2 microphone stands we have in either aisle. Quick question though, what do you think is the biggest issue the telecom industry has to face today?
The biggest issue the telecom industry has to face is self-cannibalization. They have a lot of subscribers on a very old model, and they don't really want to fire them all and give up that money, but they also want them to go and buy something different. So it's similar to the record industry, not wanting you to get like MP3s downloaded versus buying CDs. You know, there's still a market there. You got to transition. So telecom has to figure out how to change without being the same, but being the same makes them all their money. So when you have a really big organization like that, it's a very slow moving process.
Awesome. Thank you. So do we have any questions from the crowd? And Devin, virtually? Nothing? Going once? Going twice? Sold. All right. Well, thank you, Tony.
Yep.